Your engineering org probably spent 5 or 6 figures on AI coding licenses and tokens last year. Your developers tell you they're faster. Your DORA metrics say something different. The question isn't whether AI helps, it's whether your senior engineers, the ones who carry your production systems, are actually getting faster or just generating more work for yourselves. Let's get into it. We got a lot to look at this from a few angles today. What the data actually says, who benefits, the strongest case for productivity gains are real and coming, and why I think that your org is measuring this is the real problem. By the end, you know exactly where I land and what to do Monday morning. That might be today. All right, so in July 2025, METR, the Model Evaluation Threat Research Lab, published a randomized controlled trial with 16 experienced open source developers completing 246 real-world tasks on production scale repositories, averaging 1 million lines of code. Developers used Cursor Pro and Claude 3.5 and 3.7 Sonnet when it was available, the frontier models. The headline finding, developers with AI tools took 19% longer, yet they believed they were 20% faster. Simultaneously, Pharos AI published telemetry from 10,000 developers across 1,200 teams showing high AI adoption. These teams completed 98% more pull requests, but saw PR review time increase 91%. Opsera 2026 AI Coding Impact Benchmark released January 29th. I love accepting these cookies. 2029 took from, I'm on the wrong screen. So this benchmark from Opsera says that the senior engineers captured nearly 5 times the productivity gains of junior engineers, which means that the average is hiding a distribution that should change how you look at your deploying these tools. So this doesn't surprise me. Senior engineers with tools in their hands, and I've seen this firsthand. You know, it's they're able to think through problems a lot faster than maybe early career engineers because they've seen more. I find it myself that I tend to think a little bit faster than the AI, or I know where the AI agent is going. But developers felt 20% faster when they were 19% slower. There's a distribution gap in there for sure. 42% of all committed code, GitHub says, is been AI generated lately, which is an insane thing. And the 5-to-1 ratio for senior engineers to junior engineers, it kind of makes sense. It kind of makes sense. So before you call this a productivity myth, let's look at who's actually winning. Opsera's data from 2,500 developers shows that senior engineers are seeing 5 times the gains of junior engineers, right? And Google Chrome has this mechanism where if you have deep fundamentals, AI is the force multiplier, not mechanism, sorry. They have this theory that if the engineers are more senior using these tools, that it's a force multiplier. But if they're weaker engineers, and I don't want to say weaker, I just want to say like maybe they haven't seen as many problems as senior engineers may have seen, then it's not as effective and sometimes can be a hindrance on them. So this is not an even distribution of how we should be looking at this. You know, so we have speed versus trust. There's 3 gaps: trust, acceptance, and organizational delivery. This is something that everyone should be paying attention to, right? So here's the headline: experienced engineers are 19% slower. The bottleneck is fixable. High-performing teams in Pharos saw that 55 to 70% faster delivery by pairing AI adoption with upgraded review pipelines and test automation. So this is something that I've seen. What happens is the coding part, where the agent gets a little bit more in depth into what's working. So the agent gets a little bit more in depth in what's working, and then what gets blocked up is that it starts to highlight other areas of your process that are slow, right? So the generation of code, the actual like output of the engineer writing the code seems to be remarkably faster because it's able to just write all these tokens at once. However, it starts highlighting other areas of your development process that might not be up to snuff. So what I mean by that is if you have really fast code generation, but you start to see that your deployments are taking longer, your review process is taking longer, your time to fix things is taking longer, your pipelines are slow. So you can add let's do a car analogy. If you add a super fast engine to a car and you expect the rest of the car to just immediately perform better, that's not going to happen. At least that's not what we're seeing here. In fact, what we're seeing here is that the engine in the car has a net negative, according to the study, has a net negative approach. So while you might feel faster because, I don't know, the car's making some sort of a room engine, you're not exactly getting the performance gains that you want. This kind of reminds me of something I heard in college about Robert Solow. I can't remember his name. He said you could see the computer age everywhere except in the productivity statistics. And I think we're seeing that again, right? So if you look at the 1970s and the 1980s, when computers were starting to become everywhere, there was no net economic gains for nearly 2 decades. It was visible in every office you went into. I mean, I was a little kid back then, but every office you went into had computers and they were starting to adopt it, thinking that they were going to get these big performance gains. But what ended up happening is that this didn't actually, you didn't get to see crazy performance gains until businesses started completely changing how they worked. Right. So before email was a thing, everyone, sent memos and fax machines. I think we're seeing that now. We have these studies and we should be paying attention to them. But, where I land is that AI is a conditional accelerant on this, right? They make senior engineers faster with strong engineering disciplines. And that's what you should be paying attention to. The METR study is not proof that AI doesn't work. It's just proof that AI amplifies your existing practices. So if your review pipeline, test coverage, architectural discipline is strong, AI is going to compound those gains. However, if they're not, it's going to create more PRs, more incidents, more confidence in bad numbers. And the actionable thing is stop rolling out AI licenses org-wide. Start auditing which teams have process foundation to absorb AI speed throughput. Hacker News has a huge thread, AI adoption and Solow's productivity paradox, right? Taking a look at this, or we're going to go back. Yeah, open that. Thousands of CEOs just admitted that they had no impact. You have to subscribe to so many things. It's creating a paradox from 40 years ago. This is what parallels here, right? AI can slow down seasoned developers by 19%. That's what we're seeing. So we're running out of time here, but here's what I'm going to tell you. Open your team's DORA metrics, see what's going on. All right. Pull change failure rate, time to restore. Try to see what PRs are being absolutely hugely generated, because I've seen 50, 60, 75 PRs. You're going to lose quality if you start introducing that much quantity, right? Check your CI/CD incident dashboards, run queries to find out if PRs created in the last 30 days are leading to more incidents. And if there's one thing that I can say for you today is that AI doesn't necessarily make your team faster. It just makes your engineering practices faster. And if you don't have those practices, you're paying for a 30% higher change failure rate at $19 a seat. If you have actually benchmarked your team's DORA metrics before and after AI adoption, I want to see those numbers, right? Like, I put them in the comments, reach out to me, specifically change failure rate and PR review time, because I'd be willing to retract the 30% CFR claim if your production data shows otherwise. And I would like to see it. All right. If you want another 8-minute take on what actually happens for production AI engineering, hit subscribe. I'm out.